the two resistances are the same for each light bulb. Now we have 3 light bulbs in parallel with each other, and the brightness has not decreased. Each of these 3 light bulbs have 3 volts across them, and so the same amount of current is flowing through each light bulb. Now the only thing that has increased is the total current being drawn from the battery, because it's powering 3 light bulbs, so it takes more energy from the battery. So make sure you understand that whenever you have multiple light bulbs connected in series, the brightness will be reduced, because the current flowing through each light bulb is reduced. But whenever you have 3 light bulbs connected in parallel with one another, the brightness remains the same because the current flowing through each resistor is the same. But the total current being drawn from the battery, that is increased. It's 3 times as what it was when you had one single light bulb. Now, let's solve the series circuit and the parallel circuit. The series circuit on the left, the reason why it is a series circuit is because there's only one path for the current to flow. So those 3 resistors are connected in series. On the right, the current have multiple paths to flow. It can go through the first resistor, it can go down through the second or the third. And so that's the difference between a series or parallel circuit. Now let's calculate the current flowing in the series circuit. Instead of drawing a picture for each light bulb, I'm going to use a resistor to represent it because every light bulb contains a certain amount of resistance. In a series circuit, the first thing you need to do is calculate the total resistance. And it's just the sum of the individual resistors. So it's going to be 50 plus 50 plus 50, and that's going to give us a total resistance of 150 ohms. Now the next step is to calculate the current. So using Ohm's law, V is equal to IR. Solving for I is going to be the voltage of the battery divided by the total resistance of the circuit. So we have a 6-volt battery and a total resistance of 150 ohms. 6 divided by 150, that gives us a current of 0.04 amps. Now I'm going to convert that into milliamps. Now what you need to know is that 1 amp is equivalent to 1,000 milliamps. So we need to set up the units in such a way that the unit